we are going to be looking at, really the focus of this particular section is on collecting like terms. There's some other things in it, but for us, the biggest piece is how do we collect like terms? And so what I want you thinking about is how can collecting like terms simplify an equation? Or an expression, okay? So first of all, let's do a definition. An algebraic expression uses variables or numbers, or numbers and variables, and then a collection of pluses and minuses. So here's an example of an algebraic expression. 3x plus 4y plus 7 plus 5y to the second minus 6x to the second. Lots of variables, lots of numbers. If I just pick on this 5y to the second for a second, I'm going to just clarify a couple pieces of information here. 5 is called a coefficient. It is the number multiplying the variable. Y is the variable. 2 is called the exponent. So just a little bit of vocab for you, just to make sure we're all speaking the same language. This idea of like terms a term is each individual part of our expression. So for like terms, we are looking at each individual part, and if they have the same variable or variables raised to the same exponent. So a quick example. And then a couple non-examples. So an example. If I look at our example up above, if I think about 5y, let's make this black so it stands out. 5y squared would be like terms with negative 3y squared, or even just y squared. They all have a y and they all are squared. 3, 4, negative 7, 9, any number is like terms. I can even add it as like 1/2. And then maybe I'll just give you another one. 6x, 2x, negative 4x. Those are all like terms. Some non-examples. xy and xy squared. The y's don't have the same exponents. Those are not like terms. X to the second and 2x, not like terms. Even though they both have 2's with the x, they're in different places. Okay? We collect like terms to simplify an equation. So let's look at an example of collecting like terms. And this is what you were practicing in Delta Math. Giant expression, algebraic expression uses variables and numbers and pluses and minuses. Here's what we're going to do. 6x. I'm going to look for anything else that has an x. 2y, not an x. 7x is an x. There are no other standalone x's. So I'm going to combine those. And 6x and 7x, I add their numbers, and I get 13x. So I'm going to write 13x. Okay? 2y. 2y is like terms with minus 4y. So 2y minus 4y. 2 take away 4 is negative 2. When you collect like terms, the result is also a like term. So the exponent doesn't change. 3. Positive 3 minus 10. 3 minus 10. 3 take away 10 is negative 7. So then in my answer, I'm writing negative 7. So I've underlined the 6x, I've underlined the 2y, I've underlined the 7x, I've underlined the 4y, I've underlined the 3. I've not dealt with the y squared. What style underlining should I? I'm just going to do a box. Y squared has no friends, so it's just going to stay as y squared. It's okay that it doesn't have friends. I'm just going to write plus y squared. Okay? That's how we collect like